Good afternoon, pilot teachers, and good afternoon, students. Okay, thank you. Sit down. Our lesson today will move on to looking at more information on plate tectonics, but today I'd like us to look at how we can identify the different plate boundaries. We already found out that when we are looking at plate motion or plate movement, there are three movements that plates would usually do. One, where they come together, we call those, or we call that plate converging, sorry. When plates move away from each other, we call that diverging or divergence. And also we looked at plates moving past each other or sliding past each other. Plate tectonics are actually bounded by what we call boundaries. We can identify a plate boundary by looking at one of those features, which is called a volcano. Volcanoes would usually mark a plate boundary because where there are plate boundaries, you can expect to find volcanoes. So one of the main features that is associated with plate boundaries is that of volcanoes. If we look at an example of the Pacific plate, the Pacific plate is actually recognized, especially the boundary of the Pacific plate is recognized by the volcanoes, which form what we call the Pacific Ring of Fire. We also looked at the fact that when plates move together, when they move away from each other, or when they slide past each other, features, different features are actually created. So if we can recap and revise on those different features, then we're going to look at, first of all, divergence of plates. When plates diverge, we note simply when plates are actually moving past each other, or they move past each other, a ridge is the main feature which is actually formed. I mentioned earlier on that do not get confused simply because the plates are moving away. People might think there's going to be a gap there and a trench is formed. No. When plates diverge, they move away from each other as shown by the two arrows here. Then the main feature that is created is that of a ridge. But again, we note wherever there is a plate boundary, you can expect to find volcanoes and earthquakes are common. The second movement is that of plates converging, this time when plates move towards each other. There are a couple of features that are actually formed as a result of that. Some of those features are, we have a trench is actually formed when a continental plate meets up with another continental plate. I'll rephrase that, sorry. A trench would usually be formed when an oceanic plate meets up with an continental plate, or an oceanic plate meeting up with another oceanic plate. Then the boundary where the plates meet, then a trench would usually be formed. If we have an oceanic plate meeting with a continental plate, then you would note that the oceanic plate would be the lighter one compared to the continental plate. Therefore, subduction would occur, which means the oceanic plate actually moves beneath the continental plate. We also note that other features that can be formed as a result of the plate movement of convergence would be that of island arcs. And the island arcs are simply a row of mountains, usually volcanic mountains or peaks which come out of the oceans. And also note, volcanoes are created where plates converge. Similarly, when they diverge, we said volcanoes are common. Another important feature that occurs as a result of plates converging is also that of fold mountains. Usually, fold mountains would be found on continental plates. And a good example of the fold mountains we've looked at, that of the Pacific Ocean meeting up with the South American continent, of which the formation of the Andes, and also the Himalayas, whereby the Indo-Australian plate meeting with the Eurasian plate. So if you look at convergence, plates moving towards each other, there are also many features that are actually formed. And finally, we looked at when plates slide past each other, with the arrows here indicating that movement, and usually what is common or what could be formed then is that of a transform fault or a transverse fault. And note that, again, because we have plate movements, volcanoes and earthquakes will be common in this area. What I'd like us to actually move on today to looking at would be tectonic plate boundaries. The different boundaries, they are also given names, or there are certain terms that can be used to describing those three movements that we've looked at. And we'll start off with the divergence of plates and the term that we use to describing this type of boundary. And I'll repeat again, when I'm referring to plate boundaries, I'm looking at the edge of the plates. One plate can actually be recognized and can be divided from the other plate simply by the boundary. If you look at the boundary of a plate, then you say, okay, this is the Pacific plate. I can say now that this is the North American plate. And what is it that you look at to help you identify one plate from the next is you follow the boundary. If you refer to the maps of the world that you have on tectonic plates, you could be able to also work out the boundaries because they are black lines which show you the separation of one plate from another. Okay, looking at plate boundaries. When we look at plate boundaries then, note where plates diverge or they move away, the margin or the boundary is referred to as a constructive margin or a constructive boundary. So in divergence of plates, the boundary is simply referred to as a constructive boundary or constructive margin. Where plates converge or move towards each other, the boundary is referred to as a destructive boundary or destructive plate margin. So simply, when plates converge, the boundary is a destructive boundary or destructive plate margin. Finally, where you have plates sliding past each other, then the boundary is referred to as a passive plate boundary, or it can also be referred to as a conservative plate boundary. Okay, we'll repeat that again, or I'll go through that again. Where plates diverge, convergence, we have a constructive boundary or margin. Where plates converge or come together, the margin or the boundary is said to be a destructive plate boundary. And when plates slide past each other, the boundary is said to be passive or conservative. I would like us to refer to the information from that handout or worksheet that was given, and then we'll go through the information as presented on that handout or worksheet. Okay, looking at the second paragraph of that worksheet on the concept of plate tectonics. The concept of plate tectonics suggests that the Earth's surface layers are actually divided into large segments or plates. The plates are approximately 100 kilometers thick and therefore includes the Earth's crust together with part of the upper mantle, but measure several thousand kilometers across. A boundary, this time we're looking at the plate boundaries now. There are three types of plate boundaries that we have just looked at and that can be identified. The first one, A boundary where two plates move apart. A fissure develops, allowing hot molten rock to actually well up from the mantle and to form new plate material as it solidifies. And upon solidifying, those materials then would make up what we call ridges. The fissure is actually called a spreading or pull apart center, and this type of plate boundary is known as the constructive or divergent margin. So that's the first one we've looked at, constructive or divergent margin. And usually that is associated with plates moving away from each other. Let's look at the second one, B. A boundary where two plates collide. The more dense plate will normally be deflected beneath the less dense, and will be destroyed and absorbed at depth. Such plate destruction takes place at the zone of subduction, and the boundary is known as a destructive or convergent margin. Simply, this is the second plate boundary, or in terms of movement, it's where plates converge or collide or come together. And finally, C, boundaries where two plates slide past each other. These are referred to as shear margins, where little, if any, interactions take place between the rocks on either side and are known as transform fault margins. They are most in evidence across constructive margins, offsetting the trend of an oceanic ridge. You can refer to figure 1.4 for the explanation, or to explain a little bit more on that information that has been presented. Okay, so what I'd like us to do now, having looked at that information on the three types of plate boundaries, what I'd like us to actually move on to now is some activities, and the activities will be basically looking at listing two spreading or two constructive plate boundaries. I'd like you to also list down two destructive plate boundaries, and I'd like you to list down two passive or conservative plate boundaries. You can actually refer back to the map of the world, which contains plate tectonics and the arrow showing the different movements, as that can be also able to help you identify which boundaries are constructive, which boundaries are destructive, and which boundaries are passive. At least 3 examples. And when you're listing, don't forget, you cannot just put down one plate tectonics. You have to see 2 plates together and find out whether they are moving together or moving away to make your list. You can discuss in pairs and then have your answers written into your exercise book. I did say list three examples. Did I say 3 or I said 2? You could be correct in making a list because I'm asking you, did I say 3 or did I say 2? I said 2, okay, that's fine then. This should be easy. All you have to do is you go back to your notes on convergence, divergence, transform fault there, and that should be able to help you. It shouldn't take long for those activities. Passive plates. What you are listing are features. I don't want you to list the features that are created. I wanted you to list examples of plates, plate boundaries that is. So I'd like you to list at least 2 constructive plate boundaries and 2 destructive plate boundaries and then 2 passive plate boundaries. Simply when I talk about plate boundaries, as explained, if you look at your, where's the other handout that you had? Okay, so you see, if you look at your map, a plate boundary is simply the edge. It marks the edge of a plate, that's all. That's what a plate boundary is. So the African plate is bounded by a plate boundary. This is where it is. The Arabian plate, this is the plate boundary. In the Australian plate, that's the boundary. So the black lines are on the map there, they simply show you the boundaries. Okay, if you look very carefully at the plates, they are in motion. The arrows tell you that some are moving that way, that way, that way. And then at the boundary, you can also find that some plates are moving away from each other and some plates are moving towards each other. It's like say here and there. And yes, so it is the boundary, the edge of the plates we are looking at. So for you now is to identify which ones are boundaries that are moving towards each other, which ones are moving away from each other. Those that are moving towards each other at the boundary, what type of boundary is it? I wonder, God. They are destructive. Those that are moving away from each other are constructive. Those that are moving or sliding past each other are passive or conservative. So you make a list of the examples. So it's more or less you go back to the work we did previously, look at plate tectonics and plate movements, and then you'll be able to identify which plates are moving together, destructive. Those that are moving away, constructive. Sliding past each other, passive. Examples now refer to your maps. Okay, good. One more. Just one more, at least. Can I check what you have got down already? Okay, so you have 1, 2, Nazca, and the North American plate. Let's check. This is only for the first one. Is that the one for constructive?
Yeah.
Where is the destructive plate boundary? Okay, that's for constructive, this is for destructive, and this one? Okay, let's check the third one. You said the Nazca plate and the South American plate. The Nazca plate, the South American plate. North American, okay. So if you do have, did you say North or South America? North American, so then it's okay, yes, definitely. So you have Western Nazca, the Nazca plate is here, coming this way, and the North American plate is moving that way, maybe along the edge. But then before you come to that, there's another plate here, Cocos, so it cannot be. Double check on the last one. Okay, we're going to check. We'll check that information and we'll correct together. Okay, we go now to looking at, you can make reference to your maps of the world showing plate tectonics. I'll repeat again what I mentioned on plate boundaries. Plate boundaries are simply the edge of a plate. All those major plates, tectonic plates that is, that we've looked at, you can tell one from the other by following the boundary. And then you have the other maybe 17 minor plates, all of which have a boundary. Along the boundaries, you can actually look at the motion or the movement, which way the plate is actually moving. And if one of those plates actually is moving and it comes in contact with another plate when they're coming towards each other, then we say the margin or the boundary where they meet, it is a destructive boundary. Where one plate is actually moving and then another plate is also moving, but both are moving away from each other, then at that boundary of those two plates, then it is a constructive margin. Where you have a plate sliding past another plate, then the boundary of those two plates then is a passive or conservative margin. So all you had to do was to look at the map of the world, which contained the tectonic plates, and then identify which boundary or margin. Okay, let's go on to the correction now. We'll look at the first one. At least two spreading or constructive plate boundaries. Terence. Terence, can you give me the answer you had for activity number 1? Two constructive or spreading plate boundaries.
South American plate and African plate.
Okay, the South American plate and the African plate. You all check. South American plate, check from your maps or atlases and, sorry, not the atlases, but the maps which contain plate boundaries. South American plate, African plate, all happy that they're diverging? Okay, good. The boundary then will be a constructive boundary. Any other examples beside the South American and the African plate? Elsie. Any other examples? That's for question 1, that is.
The Pacific plate and the Nazca plate.
Okay, the Pacific plate and the Nazca plate. We all happy that they are actually diverging? Yes, definitely. So the boundary is actually a constructive boundary, the Pacific plate and the Nazca plate. Any other examples, Dorothy, that you can give for plates spreading or constructive plate boundaries?
The African plate and the North American plate.
African plate, all check, and the North American plate. Are they diverging? Yes. The African plate and the North American plate? Definitely. So therefore, at the boundary, it is a constructive plate boundary. So you can go back to the activity we did earlier on when we were listing examples of plates diverging and converging, and you would have noted that the boundary of all those plates that are diverging would have constructive, or they are constructive margins. Okay, we move on. The second question wants us to look at two destructive plate boundaries. Christopher, can you give me at least an example now of the second question? Two destructive plate boundaries. At least one.
The Nazca plate and South American plate.
Okay, we all check Nazca plate, South American plate. Are they converging? Yes, definitely. So along the boundary of the Nazca plate and the South American plate, that boundary is a destructive boundary or margin. Any other examples? Rebecca? We are looking at destructive plate boundaries.
North American plate and Pacific plate.
Okay, check the North American plate and the Pacific plate. Are we happy that they are actually converging? Yes, so along the boundary of the the North American plate and the Pacific plate, then we can say it is a destructive margin. Doreen, another example.
The Pacific plate and the Antarctic.
Pacific plate and the Antarctic plate. Everyone check on that one. Pacific plate and the Antarctic plate. Are they converging? Pacific plate, Antarctic plate? No. And that was the correction we did last time. I mentioned that that was the answer someone in the class gave and said Pacific plate and the Antarctic plate were diverging, and I said no. But then later I corrected that and I said yes, because along the Pacific Ocean you can also see mid-oceanic ridges. And where there is a ridge, then obviously the plates are diverging. So it is constructive. So therefore it cannot be an example of a destructive margin. Any other examples that we can also include? Luisa.
The Nazca and South American plate boundaries.
Okay, Nazca, South American, that was already given, is that right? Okay, another example beside the Nazca and South American. Check the plates that are actually converging. You should be able to give some more examples. Okay, Luisa?
The Eurasian and Australian plate.
Okay, good. The Eurasian plate, the Australian plate. They are actually converging. Therefore, the boundary is actually destructive margin. Okay, I think you can go back again now to make reference to all those plates that are converging for you to be able to identify them as having destructive margins. Finally, the last one. The last one, we did not actually correct this from the last time. So let's double check now on passive plate boundaries. And let's give examples of plates that are sliding past each other. Shelley. List at least, or give me an example of a passive or conservative plate boundary.
The Australian plate and African plate.
Australian plate and African plate. All check. Australian plate, African plate. Sliding past each other. Australian plate, African plate. Maybe could be possible at certain sections where the plates are not directly, where they are not directly coming towards each other or going away from each other. So yes, you can accept, especially towards the southern or to the southeastern point of where the Indo-Australian plate meets, or the boundary between Indo-Australian plate and the African plate. Definitely, you can actually say at that section where you can have it as a passive boundary. We'll accept that. Good. Any other areas whereby plates are sliding past each other? Mason.
Pacific Plate and the North American Plate.
Okay, very good. We're looking at a clear one this time, the Pacific Plate and the North American Plate. And for the Pacific Plate and the North American Plate, they are sliding past each other. So the classic example that one can see for a feature which is created as a result of that movement would be that of this St. Andreas fault, which is an example of a transform fault that is. So the St. Andreas fault is a good example showing us two plates sliding past each other. That's the North American Plate and the Pacific Plate. Any other examples? Anyone else think they can give us one more example? Any other examples? Okay, let's check this one. You can see the Pacific Plate and the Indo-Australian Plate, especially the section where the country New Zealand is actually in. So you check. And there is also evidence of plate sliding past each other in that area, especially with certain type of rocks, of which the rocks have moved away in the South Island of New Zealand. And the movement is referred to as that of plate sliding past. We have a passive or conservative. The Alpine Fault in the South Island of New Zealand is a good example also of a passive plate boundary. So the Pacific Plate and the Indo-Australian Plate, especially where the country New Zealand is. At least those three examples. Okay, to sum up now or to finish off what we have looked at on plate boundaries, we learned today that there are three plate boundaries or three types of plate boundaries, and they are the constructive plate boundaries, the destructive plate boundaries, and the passive or conservative plate boundaries. Destructive plate boundaries, these are plates moving towards each other, where one is actually pushed down under the other. And the Australia-India plate, as an example now, is actually pushing up against the Euro-Asian plate of the coast of Indonesia, and slowly sinking below it is the oceanic plate that is. We note also that for the destructive margin, subduction would usually be one of the common or the main feature that is actually occurring. Most of the features that are formed as a result of the convergence of plates, you can also owe that, especially the boundary, to a destructive plate margin or plate boundary. Constructive plate boundaries, these are simply when plates are moving apart or away from each other or spreading. And as they move apart, volcanic rock rises to fill the gap or rift. The junction between the Antarctic plate and the Indo-Australian plate is an example of this type. And again, we've made a list of some examples already. Basically, you look at plates that are diverging to be able to say the boundary is a constructive margin or boundary. The passive plate boundaries, that's where two plates actually move sideways past each other. And a good example as given is that of the St. Andreas Fault in California. And here we are looking at the North American plate, which is actually moving towards the south, and the Pacific plate towards the north. And along this area here then, we have the fault, the St. Andreas Fault that is. And that is an example of a passive or conservative or shear plate boundary or plate margin. A photograph or picture here showing us the St. Andreas Fault. It's this fault line here along this end. And here we are seeing a river course which is actually deflected. This course here, it's actually deflected by the fault running from left to right. So this is the St. Andreas Fault running from left to right. If you look at the riverbed here, instead of actually continuing on with its flow, it's been deflected following the fault. So obviously, this particular plate is moving that way, and that plate is moving that way, resulting in the divergence of the course. Once upon a time, this would have actually been connected, but because of the movement, you can see it ending up towards this side, whereas this particular riverbed towards that side. So that's a good photograph or picture then showing us a passive plate boundary, the St. Andreas Fault. Okay, and that will also bring us to the end of the lesson. What I'd like you to do for your homework is, we've looked at those words passive, destructive, constructive. I'd like you to think about it, and for your homework, write out why you think, or write down why you think this particular plate movement is associated with a constructive margin. Why do we say when plates diverge, they have a constructive margin? Why do we say when plates converge, the margin is that of a destructive margin? So it's mainly for these two. I'd like you to explain, why do you think when plates diverge, the margin is called a constructive, and why do you think when plates converge, the boundary is referred to as a destructive margin? If you can stand up now, that's also the end of our lesson. To the pilot teachers, our keyword for lesson 25 is collision. Good afternoon and thank you, students.